chaps. Okay, this is our second lesson of week 14 or 15, who knows, okay, towards the end of term. So, as you remember, we are in deep into the topic of mechanics, and we're looking now at motion. In the last lesson, you guys learned how to calculate speed, distance, and time. Okay? Today we're going to talk about something called distance-time graphs. So I want you to imagine, let's say you're going on a road trip, getting into your car, it's the August holiday, you're going on a trip towards, let's say, Cape Town. And what you can do is, you can record your mileage, your kilometers. The car records how many kilometers you've been driving. So you can start from home, press that button so it's 0, and record the distance. And every, let's say, 10 minutes or half an hour, 1 hour, record how many kilometers you've drove already. Okay? Now, some places you're going to drive faster, some places you're going to drive slower, sometime you're going to stop, you're going to have a lunch break, a breakfast break, whatever. Okay? And what you do is then write on a table, let's say if after every hour, you wrote down how far you traveled. And then you plot a graph. So a graph could be, this could be a certain graph. Okay? So that should have been the other way around. Sorry. But here, you're going to write down the time, could be in hours, for example. And here, you're going to plot the distance. How far away you are from home, or how far your kilometers, mileage is written in the car. Okay? What we're going to do now is to be able to interpret, I can't say that word, okay? Be able to read from the graph and try and use this graph to describe in words how fast and how far you're traveling. So I drew the shapes that you need to be able to to understand. So first of all, a straight line, okay? If you look at that straight line from here to here, okay? What does it mean that the graph, the distance time graph, is straight? Okay? What it means is that the distance that you move increases gradually in the same rate. Now, if the distance increases gradually in the same rate, the rate of distance is always the same, it's constant, okay? After 10 minutes, you drove that much. After another 10 minutes, you drove that much. Okay? It goes up in the same way. That means that the speed is constant. Okay? The speed is constant. So let's just write that down. Okay? So straight line means constant speed. Okay? Now, next thing we have another straight line, but this is now a horizontal line. I'll add these things at the end so you can make your notes at the end. Okay? This is a horizontal line. What does it mean, a horizontal line? Now, have a look at this. From this moment, let's put some numbers. So this is, let's say, 0. This is after 1 hour. This is 2. This is 3. This is 4. This is 5. And this is 6. Between the first and the second hour, between 1 and 2, what's happening to the distance? Well, the distance is not moving or not changing. So what does it mean that this is not changing? It means that we are not moving. In other words, we are stationary. Let's write that down. Okay? Stationary. Okay? The horizontal line means stationary. Now, what happens here? Okay? Between 2 and 3. Between 2 and 3, again, we have a straight line. We know straight line is constant speed. What can I say? How can I compare these two? Between 0 and 1 and 2 and 3. Let's ask you this way. When do you think we traveled faster? Between 0 and 1 or 2 and 3? Okay? And I think most of you were here in class, you would tell me that we traveled faster between 0 and 1. Okay? Because you can see in the same amount of time, we traveled much more than that. Okay? We traveled that much between 0 and 1, and we traveled only that much between 2 and 3. Okay? So, how can we tell when we're moving faster? When the graph is steeper, the speed is larger. Okay? So the steepness of the graph determines the speed. So this is constant speed, but slower. You rewrite it again. Constant slower speed. Fantastic. Now, between 3 and 4, again, we are stationary. Okay? It's a horizontal line. The distance did not change at all. What's happening between 4 and 5? So obviously we are moving. You can see the distance is increasing. But now we don't have a straight line. We have a curve. Curving up. Okay? Now, what does that mean? Okay? Well, we said that when the line is straight, that's constant speed. So now when the line is not straight, then probably the speed is not constant. And we also said that the speed is related to the steepness of the graph. And here, if you were to climb this hill, what would you tell me the steepness? What's happening to the steepness? Yeah, I'm sure you will tell me that the steepness is increasing. It's becoming steeper and steeper and steeper as we go along. It's starting not so steep, but then the steepness increases. So if the steepness is to do with the speed and the steepness increases, then what happens to the speed? Correct, it's increasing. So this is increasing speed. Increasing speed. Now, in physics, there's a specific name for increasing speed. If the speed is increasing, if an object is speeding up, then we say it is accelerating. Okay, so that's accelerating. Okay? Accelerating. Okay, car speeds up. Okay, it's accelerating. I'm sure you've heard that word before. Now, from here to here, again, it's not a straight line, so it's definitely not constant speed. It's a curve. The speed is changing. But what's happening to the speed from here to there? What's happening from here to here? From here to here, it's becoming more steep, so it's accelerating. From here to here, it's becoming less steep, so the speed is decreasing. In other words, it's slowing down. Okay? This one is slowing down. Speed is decreasing. Okay? And what's the word that we use for that? Some of you, I'm sure, have heard of decelerating. Hope I'm going to spell it right, but please forgive me if I don't. So decelerating. There's a double C there. Okay? So I'm just going to add a couple more things, go very quickly through it, and this is it. Okay, so to summarize, there's actually only one thing you need to remember about distance time graph. Really, only one. If you remember and understand well, then everything will come from it. The steepness of the distance time graph, okay? And I specifically say distance time graph because the next lesson we're going to look at a different kind of graph, speed time graph. But the steepness of the distance time graph, you know what steepness is, how steep the graph is actually the speed. It's actually the speed. If you remember that, everything will come from it. So, if the steepness, if we have a straight line, like here, you can see there's a straight line. Straight line, the steepness of the straight line is constant. It's the same. So, if the line is straight, that means the speed is constant. Okay? You're going to have to write down all this. So, just pause me and write that down. Okay? If a line is horizontal line, that means it's not steep at all. There's no steepness at all there. Okay? You're not moving up. That means you're stationary. Stationary means zero speed. You're not moving. If it's a straight line, but it's less steep than it was before, that means it's slower speed because it's less steep. Okay? If the steepness increases, it's a curve. As we go along, the steepness increases. That means the speed increases, and that's acceleration. And if the steepness decreases, okay, it's curving this way, slowing down, and it's decelerating. Okay, copy this down, please, and then do the worksheet below. Well done, guys. See you next lesson.